working on the bass boost amplifier, the end amplifier that I've published earlier. It's here, by the way, and I've made by purpose small LED so that I can always see that it is on or off. Of course, this is still experimental. Anyway, no problem. The idea of this video is how to find out the right resistor out of that 40 volts supply to supply the pre-amplifier. And the pre-amplifier is here. Of course, I still have to do all the experiments to get the maximum bass boost out of it. But this pre-amplifier I want to work, that it works on 8 volt or 12 volt. I found in the past, and perhaps that's not conclusive, that on 8 volts I could get more bass out. Not conclusive, only say a first idea during some tests with this type of amplifier. So my idea is to use here 8 volts, and it has to come out of this amplifier, and that's 40 volts. So I made this schematic to show the whole idea how to find the series resistor when you have an end amplifier on 40 volts, pre-amplifier on 8 volts. It means, of course, that we need here a resistor. Say a resistor with a certain voltage drop. And I've made here no more other indications because I don't know what kind of preamp you want to use, how much current it takes, etc., etc. So my approach is experimental and say on the safe side. This is the end amplifier. The input is now shortcut to prevent hum that's picked up, but I will say open that shortcut in this video to show more about the circuit. This is Rx, and you can do a calculation, but say this is here the preamp also acts as a kind of resistor. That means that we have here a voltage divider between the unknown resistor and perhaps even the unknown, but in some cases the known resistor here. You can also connect here a fixed value resistor, so that you have here a say purely ohms voltage divider. Anyway, good idea always is to use here a 470 microfarad capacitor. That means when the voltage is generated here, and by the way it's completely smoothed out here, so no problems with that, but that means that you have here also a filter. This resistor and that capacitor both act as a filter to suppress hum on the power supply lead, and that's here. So when this power supply lead is not properly stabilized, it transports some ripple. This resistor here and that capacitor here can help to push the ripple down to the preamp. And of course, preamp is a sensitive unit, and it must be supplied in audio amplifiers with a voltage that is as pure as a battery. And I've talked a lot about that, so want to refer to the earlier videos to my YouTube channel, and I will perhaps give the link. So my approach is experimental. I've connected here a voltmeter. That is this voltmeter. It's parallel to the preamp, and now this is Rx. And Rx, say You can do the calculation, but you can also say start with a resistor that has a too high value. When you have some insight in what's happening in such a circuit and the relation between the two resistors, try, for instance, at first, in this case, by the way, 47,000 ohms. And here I've, for my first experiment, used 27,000 ohms. Let's see what I take it now apart. You could see here now that the voltage with that 27,000 ohm resistor is approximately 5 volts. So I bridged it with a resistor of 15,000 ohms here. I do that now, so now we have the combination of these two resistors, and now we are on approximately 8 volts. That's important. And furthermore, so you can do that experimental. And when you have here capacitors that can handle higher voltages, there's no risk that you damage electrolytics or whatever. I've shortcutted the input of the end amp, and now leave that shortcut open. And that's also important when you want to say get an idea about an ideal resistor. Now open it. Now we hear that hum, and it's important to say design that resistor also for a situation where your end amplifier here gets its maximum input. That means that the voltage here, when your say power supply is not stabilized, and in this case it is not stabilized, it only has a hum suppressor, that means that this voltage can drop a little bit when your amplifier starts to take current. So let's see the effect when I do that on the voltage to the pre-amplifier. Now we are on 8 volts. So you see a substantial voltage drop to your pre-amplifier, and when your end amplifier receives a signal on its input, and that means that in reality, though this circuit is not very critical, but when you have a critical preamp, it means that in reality it can take, in theory, sometimes in practice, out the bias of your preamplifier. There are some certainly things to say to solve that problem. Use here, for instance, a stabilized power supply, transistor, or a 7812 chip, etc., etc. Often that's not not necessary when the preamp doesn't have a very critical supply voltage. But anyway, do it again. So the voltage falls back when the end amplifier gets its maximum signal to approximately 7 volts. My idea is that it is not critical at the moment. That's my idea. But when it proves to be critical, say when you get distortion out of your preamp, when your end amp starts to take current, you need a stabilized voltage supply. And you can realize that stabilized voltage supply in this power supply lead that goes to the end amplifier, but you can also realize that stabilized voltage supply not only for the end amp, or not for the end amp, but only for the preamp. Anyway, these are the considerations. Take the best out of it for your practical experiments, your homebrew audio amplifiers, etc., etc. Wish you luck. And some pen over. I shortcut the input again so that the amplifier doesn't pick up hum on its input. So in general, good idea, do this test experimental, and when you have problems, when the voltage to your preamp must be stabilized, use a stabilizer. But often these simple circuits with one transistor or two transistors are not very easy to be taken out of their working point, thus out of their bias.